Yes, hello. So my name is Yogesh and we are doing the standard 11, chapter number 5. So far we have completed chapter number 1, 2, 3. So today we are going to start about chapter number 5, the skewness of frequency distribution. So what is the name of the chapter you are doing? Chapter number 5. Skewness. Now what this skewness is about? Okay. I'll get you to the topic skewness. Before starting the skewness, I would like to tell you that you had done in chapter number 3 mean median mode, three type of measures of central tendency we had seen. Okay, chapter number 3 was about measures of central tendency in which you have done the topic mean median and mode. Now you very well know about this mean, median and mode. Now this three can be same or not. Do you remember that? Is there any circumstance or situation where what I mean to ask that does this three can be same or they are always different? That is my main question. You have observed in the chapter that mean can be same, median can be same, and mode can be same. Yes or no? Yes, it can be same. There is no rule that they are different. It can be same and it can be different also, but obviously. Suppose if the digits are like this 5, 5, 5. Now here if you will find you will get mean 5, median 5 and mode 5. So if digits are common then all three will be same. Now why I am teaching you like this? If all three are same, if all three are same in any kind of distribution or any kind of sum, then then that distribution is known as symmetric distribution. Okay, that distribution is known as symmetric distribution. Now, what this symmetric distribution is? Vice versa, both are same. Symmetric distribution means when mean, median, mode is same. Okay, so you got that thing. First of all, you have to learn this. What is symmetric distribution? Now, skewness is just the opposite of symmetric distribution. That means if I say that there is a day, means obviously there is no night. You are getting the reverse. That means if there is a symmetric distribution, if there is a symmetric distribution, then there is no skewness, or you can say that skewness is zero. It means that skewness is zero. It means skewness is zero. So again, let us repeat the whole circle once again. What I told you that if mean is equal to median is equal to mode, then it is known as symmetric distribution. Now, if the distribution is symmetric, that means there is no skewness. Now, what this means? This means that if if there is a skewness, then this three, that is mean, median, and mode, won't be equal. Okay. So if once again let us revise this complicated situation. If mean is equal to median is equal to mode, that means there is a symmetric distribution. If the distribution is symmetric, that means there is no skewness. That means if skewness is zero, mean, median, mode are equal. Now, if I want the skewness, here there is a no skewness. See, here the situation there is no skewness. If I want skewness, here there is no skewness. If I want skewness, then mean, median, mode are not equal at all. So now there are two type of skewness actually. One is positive skewness and one is negative skewness. Now what this yes, positive and negative skewness. Now what this positive skewness mean and what this negative skewness mean? This positive skewness mean greater than median. Median is greater than positive skewness means mean is greater than median and median is greater than. What this negative skewness means? It means mean is less than median and median is less than mode. So in positive skewness, mean is greater and mode is smaller. In negative, it is reverse. Mean is smaller and mode is greater. These three digits will always be in the sequence. Sir, they can be equal or not? Yes, they can be equal. Sir, if this three will equal, then what will name as positive or negative? Just remember, if these three are equal, then you would have named it as zero skewness. That means symmetric distribution. They are not equal. That's why we have two kind of types, positive and negative. And these three are in such a sequence that mean, if mean is bigger, then median will be smaller and mode will be smaller than that. There will be no any situation like mode is in between mean and median. Okay, no. Median will always be in the between. Okay, now if mean is smaller, median will be greater and mode will be greater than median. Okay, so you got hierarchy. This is the perfect hierarchy. There is no change in such an hierarchy. Okay, so now what what does we have in this chapter? What this chapter offered to us? This chapter offered to us two type of methods. One is in a Karl Pearsons method and one is Bowley's method. So we will be studying both the methods. And I tell you that both the methods are in your syllabus. There is no reduction from these two methods. Last one small point is reduced, but that is only one or two sums. Hardly. Okay. Now, let us start with the formula that is Karl Pearson's method. See, you can see on the screen there are two kind of formulas with this. One is Karl Pearson's method and one is Bowley's method. So we have to do Karl Pearson's methods. Karl Pearson's Bowley's method. Today our starting is Karl Pearson. Now, in Karl Pearson's method, see, you have two things to find. You have to find skewness and you have to find coefficient of skewness. There's two things you have to find. You have to find the skewness and you have to find coefficient of skewness. Now, what is the skewness and what is coefficient of skewness? We had a discussion that there are two kind of things. One is absolute and one is relative. If it is measured in unit, if it is measured in unit, that means it is absolute measure. Unit means 5 kg, 5 meter, 5 marks, 5 runs, like that. If it is not in the terms of any units, say for example percentage, it is not in unit at all, then such units are known as a relative measure. What is known as relative measure? So you have two kind of measure. One is skewness and one is coefficient. Coefficient is used for the comparison. Relative measure is always used for the comparison. This absolute and relative measure you would have seen in chapter number 4 also, or you can listen what I repeated just now, what I discussed just now. Okay. So as I told, skewness is absolute measure and coefficient is relative measure. So you have to find both. Now we have a formula for both the things, and skewness is denoted by SK. Skewness is denoted by SK, and coefficient is denoted by G. Coefficient is denoted by G. Now skewness is equal to. Now what are the formulas for skewness? So in Karl Pearsons there are two different formulas, but we'll be starting with the basic formula. Basic formula is skewness is equal to mean minus mode. Okay, in simple sense, it comes at mean minus mode. Okay. Visually, you can see like this. It's mean minus mode. If you want to find, if you want to find coefficient of skewness, now if I tell you to find coefficient, what is formula for coefficient of skewness? See, mean minus mode will remain constant. We have to divide it by S. S stands for standard deviation. Okay. So here, x bar is equal to mean. Okay. MO stands for mode, and S stands for standard deviation. S stands for standard deviation. X bar stands for mean. So first of all, you all have to learn this formula. Then we'll continue further. So let us start with some small sums so that we can easily understand how this skewness works. So let us take the 5.1 first sum, that is the following distribution shows demand of 500 ml pouches of pasteurized stone milk with 59 consumers. Find the Karl Pearsons coefficient of skewness in the data. Demand of milk pouches, that is 1, 2, 3, 4, 5, 6, 7, 8, and the number of consumers 2, 7, 10, 5, 12, 7, 4, 2. So how we have to do the sum? First of all, I will be writing the question. Then I will be writing the sum. The exercise 5.1. Sum number 1. So demand of milk pouches will stand as x for us. So let us write x X is 1, 2, 3, 4, 5, 6, 7 and 8. This is X for you. Okay. Now, so we'll be writing frequency. Now I have to find the skewness. Now what is the formula for skewness? Formula for skewness is mean minus mode. So you have to find mean first, then mode. Okay, we have to find the coefficient of skewness also. You can see in the question, the following distribution shows demand of 500 ml pouches of pasteurized stone milk by 59 consumers. Find Karl Pearsons coefficient of skewness from this data. So you have to find coefficient of skewness also. What's the formula for coefficient of skewness? The formula for coefficient of skewness was mean minus mode upon standard deviation. I am writing in this sum and we are solving this sum, so it's fine. See, again I'm telling you, you have to learn the formula. In formula, in skewness formula, it's mean minus mode. So the first step is to find mean. Now to find mean, you should know the formula for mean. Okay, you very well know the formula for mean. What is formula for mean? Mean is equal to sigma fi xi upon n. Okay, it is sigma fi xi upon n. Skewness we will find on the later part. So x bar is equal to sigma fi xi upon n. Now to find fi xi, we have find a column of fi xi. Let name it as fi xi, not f. Both are same, but we have named as fi. How to find fi xi? 1 2s are 2, 2 7s are 40, 3 times are 30, 4 into 15 60, 5 are 60, 6 7s are 42, 7 4s are 28, 8 2s are 16. Now you have to do the total of this fi xi. It's 2 plus 14 plus 30 plus 16 plus 42 plus 28 plus 16. That is 250. So let us make the total 250. How to find mean? Sigma fi xi upon n. Sigma fi xi is 252 upon n. Now what is n? N is the total of frequency. Now what is total of frequency? You have to do the total of fi. It's 2 plus 7 plus 10 plus 15 plus 12 plus 7 plus 4 plus 2. It's 59. Okay. You can see the total of frequency in question also. It is told that pouches of pasteurized milk by 59 customers. So your frequency is 50. So to find mean, it's 252 by 59. Now what is 252 upon 59? It is 4.2. 4.2. So this is first step I have cleared. Okay, to find the mean. Now I'll find the mode. Now how to find the mode? Now how to find the mode? How to find the mode? This is fi xi. Mode is what? The frequency which is the observation which is repeated highest time. So I'll go to the frequency. In frequency, which is the highest frequency? The 15 is the highest. So the observation which is opposite to highest frequency will be my mode. Okay. When fix is given, mode is very simple. So mode is equal to 4. Okay, the observation facing the highest frequency. So you got mean also and you got mode also. So now if I tell you to find the skewness, the answer is very simple. We had skewness here. It is mean minus mode. What is mean? 4.27. What is mode? It's 4. So our answer is 0.27. Okay. So our answer is 0.27. Then this is your skewness. If you want to find coefficient of skewness, which is denoted by J, your formula is mean minus mode upon standard deviation. So you have to find the standard deviation. Now to find standard deviation, there is a formula. Okay. And there are two formulas to find the standard deviation. You can use any of them. We are using fixi square upon n minus x bar whole square. And this everything is in the root. Standard deviation is sigma fixi square sigma fixi square minus x bar whole square upon n. Now, if you want to find standard deviation, your formula is sigma fixi square minus x bar whole square upon n. See, you have x bar, so there is no problem for that. Formula is like this. Let us change. It is exact like this: sigma fxi square upon n minus x bar whole square. That n was not in the common. Now to find fixi square, you need to put in column fixi square. Now we had a discussion in standard deviations chapter that this fixi square is what? Okay. Once again, I'll be discussing the same point. This fixi square means this fixi square means it doesn't mean the square of fixi. See, I'm clearing my words. Fixi square is not the square of fixi. It is fi into xi into xi. It is like this. Okay, fixi square is fi into xi into xi. Okay, this is fixi square. It's not fixi whole square. See, if I would have written like this now, fixi whole square, then this would have a different effect. This would have meant that I had to do the square of fixi. This is fixi square. This is different. It means fi into xi into x. Now, how to solve this? See, to solve this fixi square, just pay the attention that I had already fixi here. Just I have to multiply it by xi. Okay, so if I'll multiply this xi into fi, see I have fixi. I'll multiply just xi to get fixi square. So I'll multiply this two particular columns. You can see here. So it's fixi into xi. So 2 ones are 2, 14 twos are 28. Let's change the color. Then 30 into 3, 90. 16 into 4, 240. 16 into 5, 300. 52 into 6, 252. Then 28 into 7, 196. 16 into 8, 120. So it's 2 plus 28 plus 90 plus 250 plus 300 plus 252 plus 196 plus 120. That's 1 2. Now I got the total of this, that is fxi square. Okay, 1 2 3. What I have to do, I have to simply put this 1236 here. So you will get 1236 upon 59 minus 4.27 square. What is 1236 upon 59? It's 20.95. So it's 20.95 minus 4.27 square. 4.27 into 4.25, that is 18.20. Now 20.95 minus 18.20. Now this root of 2.72 is 1.60. Now this 1.65 is a standard deviation. Find this coefficient skewness. It's mean minus mode upon standard deviation. So mean minus mode upon standard deviation. So it's 0.27 upon 1.65. 0.55. 1 minute. 0.27 divided by 1.65. For 0.16. Coefficient is 0.1. So this is how we solve the sum. You can see here. First of all, we had find the mode. We had found the mode. Mode was sigma fi. First we found the mean. Mean is fx upon n. Then we found the mode. Then we found the standard deviation. Okay, you should learn the formulas first. Then and then only we can proceed with this chapter. Okay, so next day we'll be continuing this particular. Okay, that's all for today.